I saw this question on YouTube, and it was done by algebraic factorization. It's quite complicated, but here I'm using different methods. I need two different methods. Now, here is the first one. Now, from this equation that we can see this x minus 1 over x is equal to 10th root of 1. So I can find 1 over x is equal to 1 minus 10th root of 1. What's 10th root of 1? 10th root of 1 is a complex number, which is a cosine theta plus I sine theta. Theta is a n pi over 5. What that means, it's a complex number on the out of 10 points on the unit circle. This is a unit circle. Radius is equal to 1. And the 10th root of 1 are 10 points on this circle. They're equally apart. So every angle is a 2 pi over 5. So this is a pi over 5. This is 2 pi over 5. And 3 pi over 5. 4 pi over 5. This is 5 pi over 5. This is negative pi over 5. This is negative 2 over 5. Just fifth pi away. So this is a negative 3 pi over 5. This is negative 4 pi over 5. So we have a 10 roots of a 1, 10th root of 1. These are 10 points. Okay. So n is equal to 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4. These are 10 points. Okay, 10 angles. Now let's come back for x. We're looking for x, right? Yeah, so x, 1 of x is equal to 1 minus cosine theta minus I sine theta. Okay, this is 10th root, this is this. Now, therefore, x could be found. It's equal to 1 over 1 minus cosine theta minus I sine theta. Now, we multiply conjugate, right? This is this 1 times 1 minus cosine theta plus I sine theta. And the same thing on top. 1 minus cosine theta plus I sine theta. Okay, let's keep away from this unit circle. All right, good. Then x is equal to, now the denominator, this minus this plus that is equal to this square minus that square, right? I square is negative 1, so it becomes plus. So, yeah. The numerator is a 1 minus cosine theta plus I sine theta. And this one is equal to, this is 1 minus 2 cosine theta plus plus sine cosine square plus cosine square is another one, right? Yeah. And this is 1 minus cosine plus I sine. So this is obvious equal 2, right? This is equal to x equal to 1/2. This over that one is 1/2 plus half I. This is sine theta. This is 1 minus cosine. Yeah. Okay. Just this one is equal to 1/2 plus half I. This is twice sine half theta, cosine half theta. This one is 2 sine square half theta. So finally, we find x. X is equal to 1/2 plus plus 1/2. 2 cancel, sine cancel out, it becomes cotangent half. This is my x. This is my x. Now, we just put a theta back. This is theta. This is theta. Yep. Okay, so when x equals to 0, when n equals to 0, n equals to 0, this is theta is 0. Cotangent 0 is not defined. So 0 is not good. Okay. That's right. And how about this one? This pi over 5, put it there. This is a half plus or minus half I cotangent. And this is a 10 pi over 10. Okay, these are two roots. And half plus or minus, when we put this plus a 2, 2 pi over 5 over 2. 2 pi over 5 over 2 is equal to cotangent pi over 5. Yeah. And next angle will half plus or minus half I cotangent 3 pi over 5 is 3 pi over 10, right? For n equal to 3, yeah. Then plus or minus half cotangent 4 pi over 5 over 2 is 2 pi over 5. Right? And also have this one. This is when n equal to 5. This is the same, theta is a pi. Pi over 2, cotangent half pi. When n equal to 5, theta is equal to pi. Pi over 2, cotangent is a 0, right? Therefore, 1/2 is another. Okay, that is this when n equal to 5. So these are 9 roots of this equation. Okay, that is x. Why 9? Well, because when you expand this binomial, x to the 10th power cancel with that one. So leftover is polynomial degree 9. So we have 9 roots. So here we have 9 roots. Okay, this is a method using the unit circle. Okay, now second method. Second method. X10 is equal to x minus 1 to the 10th power. Okay. We suppose that x is we're looking for x. X must be a complex number. Is r cosine theta plus I r sine theta. That is x. And also we know that from this one, 1 minus 1 over x to the 10th power is equal to 1. Yeah, from this equation you have this one, right? So what is the 1 over x? 1 over x is equal to 1 over r cosine theta minus I over r and sine theta. So this means that 1 minus that, right? 1. So 1 minus 1 over r cosine theta, that will be a real part. Yeah, plus I r sine theta. Yeah, to the 10th power equal to 1. Based on this one, right? 1 minus this one is equal to this. Yeah, that's correct. Now, this means that this complex number, 10th power equal to 1. Therefore, the modulus of this complex number must be 1. The modulus, the norm, okay. Therefore, the real part, 1 minus this is square plus 1 over r sine square must be equal to 1. Because the real the modulus equal to 1. This one is equal to, this means this minus 2 cosine r plus cosine square theta over r square plus sine square over r square equal to 1. And 1 cancel out, right? So 2 cosine theta over r plus 1 over r squared. This plus this is equal to 1. Is equal to 0. So from this, we can find cosine theta is equal to 1 over 2r. Yeah. Now we put it back, therefore we find x is equal to r cosine theta plus I r sine theta, which is equal to, put cosine equal to this back, this r equal to half plus I r sine theta. Yeah, it's interesting that our x, the real part is half. Okay. Which means that this is half, right? X must be on this line. Okay. This is theta. This is R. This is X. X is a complex number. R is a modulus. This is the argument. Now, this one is equal to R times sine theta, right? That's imaginary part. Because this is half, this vertical line could be 1/2 times tangent theta. This could be 1/2 times tangent theta. Therefore, x is equal to 1/2 plus uh, 1/2 over tangent theta. Yeah. So this is better. So this is our x. We find a theta, we find x. So how do we find a theta? Yeah, this is another interesting. From this equation. So this equation have a two complex number. One is x minus 1. Okay, so x minus 1 is another complex number, which is equal to -half plus I over 2 tangent theta. That is my x minus 1. So if I use the picture to show it, this is my x. This is 1/2, right? X is on this line. And x minus 1 is on this line. X minus 1 is on this. They have the same imaginary part. Therefore, if x is here and x minus 1 will be there, this is x minus 1. If x is here, x minus 1 will be there. Okay. This is theta. Right? This is theta. Yeah. It's very interesting. Now, we're looking for theta. If we find a theta, we find x. Now, from this equation says that this complex number, which is this, and that one complex number, that is this. Their argument after 10 times, based on the Moire theorem, 10 times this argument is equal to 10 times that argument. X argument is this, right? X minus 1 argument is this. Yeah. Suppose this is, yeah, this is phi. Theta. Okay. This phi is argument of this complex number. Theta is argument of this complex number. Based on this equation, 10 times this argument is equal to 10 times that argument. So in other words, well, let me have to write it. Theta, phi is equal to phi equal to pi minus theta, right? Pi minus theta. And 10 times this, 10 times this, 10 times this argument, which is theta, is equal to 10 times this argument, which is that. Yeah. And of course could be plus or minus 2 pi n pi, right? Yeah, from this equation, we can find that theta is equal to pi over 10 phi plus n. If, well, we just find theta by choosing value of n. But theta cannot be more than half pi because the point must be on this line. The theta cannot be more than half pi. Cannot be less than negative half pi. That is the condition for theta. So we choose n to find theta. Okay. Yeah. N equal to 1, n equal to 0, this will be half pi. Half pi is not good. Must be less than half pi. N equal to negative 1, theta will be equal to 2 pi over 5, right? Yeah. N equal to negative 2, negative 2 will be 3 pi over 10. N equal to 3, negative 3, yeah? This theta would be equal to negative 3, would be pi over 5. N equal to negative 4, theta would be equal to negative 4 is 1, right? 10th or n equal to negative 5, theta will be 0. 0 is okay. See? As long as it's between minus half pi and positive half pi, theta is okay. Then n equal to minus 6. This theta will be equal to 6. Negative 10th pi. N equal to negative 7. Negative n equal to 8. Minus 3 pi over 10. N equal to 9. Negative 9. Theta is equal to, right, 2 pi over 5. Yeah, n equal to negative 10. Well, it's not, then it's not good because it's a negative half pi. It's not good. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a 9 solutions for theta, which is 9 solutions for x. So let's continue to finish it. So x is equal to half plus half I tangent theta. Theta will be this, right? Well, this and that, we can combine it. Because 1/2 plus 1/2 plus or minus tangent. Yeah. 2 pi over 5. This one and that one. Okay, this one pair. And is equal to plus or minus half I tangent. These two. 3 pi over 10. 1/2 plus or minus half I tangent this, yeah. Yeah, and another pair which is equal to half I tangent, right? This one and that one. This one and that one. And also theta equal to 0 is also okay. And 0 is 1/2. So these are 9 solutions for our x. Yeah. Well, method 1, we cotangent. Method 2, tangent. Well, they are the same because 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 it's half pi minus theta is equal cotangent is equal to tangent theta, right? So if you half pi minus this, half pi minus this one will be half pi minus 2 pi over 5. This will be 10 pi, right? See, that is, in other words, yeah, this angle's tangent is equal to this cotangent. See, you can check the other one. You can check the other ones. They are equivalent, because the angles, the complementary angles. I don't need to check the others. But anyhow, these sets of solutions are the same, but they're using different methods. And I found these two methods are very, very good, very interesting. Thank you for your watching.